The world of water. So I'm going to be talking about water more in the medical field and how life would be if the properties of water were different. So water is used in hospitals for many different things: hydrotherapy, ingestion, dental tools, cleaning equipment, all that. So here's some basic water facts. Water is a covalent bond that shares electrons unequally. So this is a bond. So hydrogen has an electronegativity of 2.1 and oxygen has 3.5, giving it a difference of 1.4. So therefore the bond is polar because it is greater than 1. Oxygen has a greater electronegativity, so it is drawing the electrons toward it, giving oxygen a slightly negative charge, and hydrogen now has a slightly positive charge since the negative is pushing toward oxygen. This is water, H2O, the molecule form. So as you can see, since oxygen has a higher electronegativity, the electrons move upwards. So this creates the molecule to be overall polar because the electrons move all the way up, so it's very unequal, and hydrogen is more slightly positive toward the bottom. So now we're going to talk about intermolecular forces. So an intermolecular force is an attraction between two or more molecules. So H2O has a hydrogen bond, which is a type of intermolecular force. So happens when hydrogen, an atom of one molecule, is attracted to a highly electronegative atom such as oxygen or nitrogen. Other types of intermolecular forces that aren't in water include dipole-dipole and London dispersion forces. So right here's the hydrogen bond for water. As you can see, oxygen has the high electronegativity, so the electrons move more downwards, and hydrogen bonds are responsible for water's boiling point, which we'll talk about more in a second. So when the intermolecular forces are weak, the molecules spread apart and they make it a gas, but when these molecules are close together, it becomes a solid. So as water has a lot of uses, as I talked in the beginning, let's talk about what would happen if water was nonpolar. So water that is typically at room temperature has molecules that kind of stick together with these hydrogen bonds, and this makes it difficult for the water molecules to break and evaporate, which would mean becoming a gas. So if water was nonpolar, then hydrogen bonds wouldn't be able to form, and there would be a gas. So that would not be good in the situation of the hospital because we use water there to clean and we use it to drink. So if it was a gas, we wouldn't be able to do any of that. Another example is it's really important at a hospital to stay sanitized. Doctors need to wash their scrubs and clothing constantly and their hands because it's really important to stay sanitized at a hospital and make sure these germs aren't transferring, especially during a procedure. So in soaps and detergents, which are used to clean, they have stuff called surfactants that are in it, and it's used to clean dirt and oil off surfaces, and the molecules in them are hydrolyphic, so the molecules are attracted to polar water molecules, which work together to clean. So if we look at life with water in a different substance, if water was nonpolar, then it wouldn't be able to be attracted to these surfactant bonds, and it would be hard to sanitize and stay clean at a hospital, which would not be good. So not only the nonpolar water would be a gas, but also soap would be not attracted to the water and it would be ineffective and not be able to clean all the germs in the hospital. So now I'm going to talk about melting and boiling points. So a melting point is the state where a solid becomes a liquid, and a boiling point is when a liquid becomes a gas. So pretty much when property melts and boils, that means these intermolecular forces are breaking. So if we're talking about water, a hydrogen bond is pretty strong, and once those molecules start to break off, this requires a lot of energy, and that's why it becomes a gas. So that's why water has a really high boiling point. So this is the same thing. If water didn't have a hydrogen bond, that means all of the water would become a gas because the bond wouldn't be existent, and the bond is what holds the molecules together, making it a liquid or a solid. And again, if all our water was only gas, we would die of dehydration, and we would also just not have water for all the necessities. So next I'm talking about solubility, which is the ability to be dissolved, and it's in water. So dissolving means mixing, and molecules, they need to be attracted to one another in order to mix. So the basic rules are polar dissolves polar and nonpolar dissolves polar. So if you put that water and oil in together, water is polar and oil is nonpolar. Therefore, it doesn't mix and it kind of just clumps in half. And salt dissolves in water because salt has polar compounds that attract to the water, which is also polar. So in hospitals, they run IVs, which is saline solution. Saline solution is water mixed together with salt, and patients need this because salt has electrolytes that help dehydrated patients. And we know if water didn't have hydrogen bonds, then it would be a gas. But if the individual bonds were nonpolar, that means the salt wouldn't mix with the water for this solution, and that would not be good. So since water would be nonpolar and salt is polar, it would not be able to mix together. And since these patients need these electrolytes and need them fast, you can't inject salt crystals into the vein. That's not going to work. These patients need saline solution in their veins. So that's what would happen if water became nonpolar in their bonds. The next thing I'm going to talk about is surface tension, which is the resistance of a liquid to spreading out or being penetrated. So, for example, if you put a bunch of water on a penny, it kind of creates an air surface type skin that prevents the water from spreading out. And so, this water and their intermolecular forces, the molecules stick together, which means the water doesn't spread out, and that means water has a high surface tension. So some other examples of surface tension are raindrops on the window, or certain bugs and spiders are able to walk on water because of the surface tension. So if we go back to the IV and we're talking about surface tension in the medical field, so our cells need nutrients and minerals, and water stickiness from this surface tension plays a role in our body and our need to transport these materials. So, as our bodies, especially in a hospital, are in need for the electrolytes and minerals that salt are, surface tension in our body helps it travel. So, if we didn't have surface tension, then our minerals wouldn't be able to spread out throughout our body. And our body needs minerals and nutrients, so that would not be good. So since water is a highly polar molecule, it forms strong covalent bonds with other water molecules. The force of these covalent bonds creates an inward force on surfaces such as lung tissues. And since lowering the surface area of the surface as the tissues pull together, this causes the air inside the lungs to be moist, which is good because our body needs this water for our tissues in the lungs to function. So if water didn't bond with other water molecules, then the air would be really dry and it would be even harder for us to breathe. So the last property of water is water may have impurities from various metal ions. So the water that travels through the pipes in different places can mix together with these metal ions. That's why lead gets in the water in Michigan. And also the taste of water can be different because the hydrogen bonds can attract these metal ions. That's why water might taste different in Switzerland rather than Swaziland. So these impurities make water not clean. So even though water can gain lots of impurities that are not good for people or make water taste kind of icky, hospitals have systems to sterilize this water and make it distilled because, like I said, it's really important that the water is clean and everything is clean there because you don't want germs going around as people are already in a lot of danger. So even if these metallic ions didn't mix with our water molecules, life wouldn't be that different because, like I said, hospitals have a way to remove these metal ions and make sure it's clean for the patients. So that's all. I hope you learned something new about the medical field and the role water has to do with it. And yeah, thank you.